Okay, so let's say a random variable x is the blood pressure of a Canadian male in between 18 and 74 years of age. Okay, here let's say that it's approximately normally distributed, where the middle of that normal distribution, the mean, is 129, and the standard deviation is given as 19.81. Okay, so what that means then originally, here's my bell curve, that's the normal distribution. Okay, so here I've got the normal shape or the bell shape. The middle is 129 and the spread, the standard deviation, is 19.81. Okay, A says find the probability that a randomly selected male has a blood pressure that is larger or exceeding a 155. So in pictures, here's the middle, this is what I expect, that's the average. And here, anybody that has a blood pressure of over 155, we want to know the probability of that. Okay, so a number of ways that you can try and accomplish this problem. We've got two scales. We've got the Z scale. This is in units measured, which is, I guess, HG, millimeters of HG, I guess. So we can convert that into the Z score. How we do that again, remember the formula is Z equals x subtract mu divided by standard deviation. Okay, so if I was going to convert this value, the center value, it's going to be this value, which is 129, subtract the mean, which is also 129. So you'd get 129 subtract 129, which is 0, divided by 19.81. 0 divided by 19.81 is simply 0. Okay, the middle of a standard normal distribution is always 0. Here to transform or to translate this 155, we would take 155, subtract from the middle, so 155 subtract 129, and take that difference and divide it by the standard deviation. Okay, I've done that. You can try it at home if you want. You could get a z-score of 1.30. Okay, so I want the probability that it exceeds 155. Okay, so I want to show you three different things. First, I'm just going to go to calc probability distributions normal. Okay, I want the cumulative area. I have the value. I want this area. Okay, when I'm talking about z-scores, the middle is 0, the spread is 1, and here the value that I'm looking up is 1.3124. That is the z-score that I found. Okay, I get something around 90%. Of course, that is the cumulative probability from the left to this point. That's why drawing pictures help. It's obvious to see this is the large side, therefore this is the small side. It's not very realistic to think that this is 90%, but this should be 1 minus that. Okay, I want to show you another trick if you're ready for it. So here, the other thing I could do is go to probability distribution normal. Okay, I know that Minitab only gives me the cumulative. So if I just play games with the fact that I know bell shape is symmetric, then here I've got 1.3, but on the negative side, on the mirror image, I'd have negative 1.3. Minitab will give me the cumulative area there. Okay, so if I put in a negative, I know that it actually is a positive, but if I put in a negative, I will get the mirrored image where it'll directly give me the probability without having to do my 1 minus trick. Okay, so here, notice I get 1 minus this answer for this answer. You don't have to do that. You can always do 1 minus on your calculator. It's just a trick to make things easier and faster. The third thing that I want to show you to get yet the same answer, instead of having the middle be 0, I could say the middle is what it actually is, which is 129. The spread is 19.18, what it actually is, and then I can look up the value that I'm actually interested in, which is 155. Okay, this is going to give me, again, the original probability that I got originally. Okay, so a good thing about using the actual middle and the actual spread is that I don't have to do the z-score conversions. The bad thing is there's no easy way to do this 1 minus trick that I showed you if you're going to use the real data. Okay, I can't just do minus 155 because that is not symmetric. This is not placed around 0. Okay, so we wouldn't want to just do minus 155. That would not be the same thing. Okay, so part B says 5% of Canadian males have blood pressure lower than what level? Okay, this is also called the fifth percentile. Okay, so what this means is, again, if the middle is 129, and here the cumulative or the percentile area is 5%. So here 5% of Canadian males have blood pressure less than what level? Okay, so here less than that level is 5%. Then I want to know what probability, sorry, not what probability, I want to know what level of blood pressure are we talking about here. Okay, so here's the answer, and I'll show you how I got it. Okay, so the first thing that I need to do, well, if I'm using a Z table, which is, I don't suggest doing this, but if you're using a Z table, I've got an area and I want this value. I don't know what this is yet. So if you're using a Z table, instead of looking on the outside of the Z table, you need to look on the inside. That's where the areas are. And this is very detailed in here, lots and lots of different digits. What I need to do is find some value as close as I can to 0.05. And then, in this case, I don't actually find the exact value. Okay, so let's see if I can bring up the Z distribution here. Okay, so what I'm doing is searching for 0.05. It's very difficult to do this, okay? So you need to try and scan, try and find it. Here are values that are close. So in between this value and this value, I don't have 0.05, but I know it's in between these two values, okay? So this is in the row negative 1.6, and in between 0.04 and 0.05. You could estimate then and say in between those is 0.005. You could say negative 1.645. You could do that. I don't suggest it. The better option is to use Minitab. Okay, so here we can use Minitab. We go to normal distribution. Okay, so again, let's talk about the standard normal, where we're talking about Z-scores. And we need to use this inverse cumulative probability. We use cumulative probability when we have this value and we want this area. When we have this area, like in this case, and we want this value, we need to use this inverse. Okay, so if I put the cumulative inverse probability, which is here, this probability from the start to this point is 5% or 0.05, then I will find that the value that corresponds here much better than using a table, negative 1.645-ish. Right, so that is the Z-score. What you can do then is to solve for an x. This is the Z, so in this formula, we'll have this be the Z. We don't know what x is, we're trying to solve for this. We know what mu is, it is 129. We know what sigma is, it is 19.81. You can then rearrange this formula and solve for x. That is one way to do this. The other way would be to go to calc, probability distribution, inverse, but actually tell it what the mean really is, 129, what the standard deviation really is, 19.18, and here the cumulative probability, inverse probability, which is the fifth percentile, or 5%. And this does the conversion for me. Okay, so you should be able to do all of these ways if you're asked to do so. Okay, notice on your midterm you have Minitab, so you can use Minitab to your advantage. On the final exam, you don't have Minitab, so you might be stuck doing the table method. You need to be able to do both, so practice both.